Okay, so we will now do this module called Similarity Analysis. Okay, so what we want to do here is compare the nodes in the network on the basis for the similarity among the metric values. So it could be, say, the metrics like weight, height, age, or characteristic of the nodes, or could be like the centrality metrics, characteristic of the topological importance of the nodes. So we will look at assessing similarity and quantifying it at two levels. One is at the node level and the other is at the network level. So at node level, what we're looking at is similarity between any two nodes in the network. So that means for every possible node pairs, we'll come up with a similarity score. And we'll look at there are several node level similarity metrics that are out there in the literature, and we'll look at what is called the cosine similarity, a very commonly used metric. And then we'll also look at assessing or quantifying the similarity among the nodes at the network level. That means we'll try to come up with one single score that will quantify the similarity among the nodes in the entire network. Okay. We'll look at two approaches for that. One is we'll extend the pairwise cosine similarity matrix or cosine similarity measure that we can get from the node level similarity approach, and build a matrix called the cosine similarity matrix, and then compute what is called its principal eigenvalue. And some people may not be familiar with it, so I'll leave it as it is here. When you come to the approach, we'll look at the eigenvalue and things in detail in a later video. So now the other approach will come up. It's called the pairwise distance between nodes and the binary search based method. So we'll compute the pairwise distance between nodes based on the features that we will have for the nodes, and then apply this well-known binary search. Binary search is a well-known method in algorithmic design, and we'll try to apply that here. Okay, so again, some people may not be familiar with it still, so we will wait until we'll come to the approach in detail. Okay, so we'll start with cosine similarity. Alright, so what we are trying to do here is come up with a vector that captures the metrics that we want to have for the nodes, and then evaluate the cosine similarity between any two nodes using this formula. So let me go through an example to illustrate this. So we have, say, a network and say the weight, height, and age of the nodes in that network. So what we want to do is come up with a similarity score for any two nodes in the network based on all these three features: the weight, height, and age. So what we are given is first the raw data, and what we need to first do is to normalize this, and we'll use the square root of the sum of the squares approach to normalize the raw data. So that means we will square all these values, sum those squares, and then take a square root of the sum of the squares of these numbers. So whatever we get, say as the normalized value, so we'll try to divide this 130 by that normalized value. So then all these data here will be in a range of 0 to 1. So that's what we have done in the past, so using the square root of the sum of the squares. So then what we do is, so we call now this as a vector. So for node 1, the vector is 0.3193, 0.305, 45, 0.2178. So for each node we have a vector of this normalized data. And then we'll apply this formula. So here what we'll do is we'll take the product of the two vectors, and then also here we square the entries in the vector, sum all those squares, and take a square root of that sum. Okay, so let's say you want to now evaluate the cosine similarity between nodes 1 and 2. So these are the vectors for nodes 1 and 2. So we'll take the pairwise product, so 0.3193 times 0.3685, then plus 0.3045 times 0.4153 plus 0.2178 times 0.4261. So that's the product. And then divided by square root of sum of the squares for each of these vectors. So 0.3193 square plus 0.3045 square plus 0.2178 square root of that times 0.3685 square, 0.4153 square plus 0.4261 square. Sum them up, square root of this. So the numerator, the product evaluates to 0.3369. The denominator, the square root of the sum of squares for the first vector is 0.4920. For the second vector it is 0.6999. So if you simplify the math, you get 0.9784. Okay. So we can evaluate the pairwise cosine similarity between any two nodes in the network with this approach. Of course, that's going to be time consuming to do it manually, so I have a program to do that, like a jar file. So later in another video I'll show you how to get this matrix of the pairwise cosine similarity between any two nodes in the network. Okay, so this will stop this video.